Okay, for today's lesson, we are going to continue talking about exponential functions, but this time we're not going to graph today. It's going to be probably a little simpler for most of you to handle this lesson. We're just going to solve equations that have a variable that's an exponent. So the lesson's on solving exponential equations. Here's our first example. Before we start doing it, let's just kind of look at it for a second. Notice we have an equation, so we have an equal sign right there, and what we're trying to solve for is stuck up here. And so we have to figure out what the trick is going to be so that we can figure out what in the world number goes there. So we take 3 to some power with an x in it, and it equals this number over here. So there's definitely a trick, and it's real simple. The trick is if we can make this base the same as this base over here, if we can write this number right here as 3 to some power, and then therefore the bases match, then we can just set the exponents equal to each other. So really this first problem's pretty easy. All we're going to do is we need to think about what 243 is. We see a 3 over here, so we figure this 243 must be set up to be a power of 3. So we can kind of go back to our old methods. We can just take 243 and start dividing. It's obviously not divisible by 2, but it'll be divisible by 3. You get 81. And then keep going. 3, 27, 3, 9, 3, 3. You got to be real careful here, because if you don't count the number of 3's correctly, the whole problem is not going to work out. There are 5 of them here. Okay, there are 5 3's. So we have this. We're going to leave the left side the way it is, but we're going to write this side like this. Now think about it. If you have 3 to some power equals 3 to some other power, the only way for this whole thing to be equal to this whole thing is if this equals that. Not too bad, huh? Pretty easy. The trick here, really, these ones come down to just being good with numbers again. We've had to deal with that a lot in this class, where some of you struggle just by dealing with, arithmetic. This kind of stuff over here. You have to be very accurate over here, and the rest will just be really simple. Simple solving equation back from 6th grade math. All right, let's do it again. All right, little trickier. First of all, we have to realize that's kind of sloppy right there. That's going to be an N. Call it whatever you want, but it's a letter. Okay, but we'll call it an N. I'll make it look nicer next time I write it. All right, same thing. This one's a little trickier though, because this is a fraction over here, and we have to realize that a fraction, and we talked about this in the last lesson when we were graphing, is really just going to be a negative exponent. So 81, let's just start with 81. Hopefully from the last problem, 81 is just a bunch of 3's also. It's 4 3's multiplied together. But that would be 81. We need 1 over 81. It's going to look something like this. How about that? Stare at that for a second. Pause it if you need to. Think about it. But isn't this the same as that? Because this would be 1 over 3 to the positive 4, but we just learned that 3 times 3 times 3 times 3 is 81. So this and this are the same thing. Why do I want to write it? Why do I want to write this like this? Because now these match. Whenever these match, whenever the bases match, we just set the exponents equal to each other. So we're down to a super simple problem. And there we're done. Told you N would look like an N by the time I was done with it. It almost like it's evolved. Look, it started here, then it turned into that, then it almost looks like an N. Hey, it finally became an N. Look at that. All right, let's do it again. All right, so this time what makes this one just a little bit different is that I can't take 36 to some power to make this. What we need to do is break down both of these numbers. We got to work on both sides this time. So we just we can go off to the side. I mean, it kind of depends on what you know about numbers. Like 216 is a bunch of sixes, but really sixes are twos and threes. 2 times 3 is 6. So, this can get a little bit tricky for you. Let's just look at it. Okay, so 216 is 2, and you get 108, and we'll do 2 again, and we get 54, and we'll do 2 again, and then we'll do 3 and 3 and 3. So here's where you got to be a little bit clever here, at least the way I'm going to show you right now. You have to be a little bit clever to realize, 216 is 2 times 2 times 2 times 3 times 3 times 3, but it's really 6 times 6 times 6. And then we can, 36 we all know is just 6 squared. So I don't really want to write this as, 2 times. I need to write it as a power. I need it to be something to a power. And they'll all be set up to be that way. So they're all rigged up. These problems are set up so that if you see twos and threes, well, there's going to be exactly the same amount of each of them because it's really 6 times 6 times 6. So it's going to be 6 cubed, that is 216, to the power of negative v equals 6 squared to the power of negative 2v. Now, I'm pausing just to let you look at that. Make sure you guys, you can pause, of course, but I mean, if you want to just keep watching the video, just make sure that makes sense to you, what I did so far. I'll even use the laser again here. This number right here, 216, is that right there. And 36 is that. So it used to be this to that power. Now it's this to that same thing. And 36 is this to that power. So I really haven't done a whole lot here. But here comes kind of the tricky move. Whenever we have something to a power and then to a power, we can just combine this together to be one thing. Same thing over here. So I'm going to do that right now. It's going to be 6 to the negative 3v equals 6 to the negative 4v. This is going to be kind of a weird problem the way it works out. But here's the deal, just kind of like the last ones we did, now these finally match and they're raised to something. They both have something here, therefore those are equal. So negative 3v equals negative 4v. What's going to make this one weird is it's kind of the answer is going to be 0. Basically because right now, if you tried to just solve it, I mean, I can stare at this, hopefully you can too, and realize that if you put a 0 into both sides, you're going to get 0 equals 0, which is good. So 0 is the only answer to this problem. But if you were just not thinking that much about it, you just wanted to solve it, you would take the v's, get them all to one side. So you'd add 4v to the other side, and you'd be left with v. So once you took this and moved it over here, add 4v, negative 3v plus 4v is 1v. But now that you move that over there, you just have nothing over here, so it's 0. And you're pretty much done. Yeah, that's it. Nothing else you can do. Sometimes they come out weird. Last one. It's not really any harder. I'm just kind of doing an extra example. You might find something a little slightly different on the homework, but not, that's part of the fun. I know, I can only do so many examples, and then it's time for you guys to kind of figure out what's going on. But one more. Here we go. It's going to be very similar. On this one, you stare at it, you see a 27 and 81. once again, you should be, especially since the other examples I did, you should know that, it's 3. And so 27 is 3 to the third power, and then it's still to the negative 3r minus 1. And then this is 3 to the fourth power to the 2r. But then, like I did on the last problem, this stuff can combine, so it's just 3 to a power, and then this is going to be 3 to a power. I'm going to take my time on it, so it's really just going to be 3 to the 3 negative 3r minus 1 equals 3 to the 8r. I could have already distributed here and all that, but I just wanted you to see it written slightly different there. Notice I didn't put the parenthesis on here anymore. I just focused on the fact that this is going to get multiplied together right there. This one, I went ahead and did it. 4 times 2r is 8r. I could have wrote 4 times 2r, but I didn't. All right, now, these match. Therefore, this has to equal that. So you get 3 negative 3r minus 1 equals 8r. Negative 9r minus 3 equals 8r. How about we just leave the negative 3 here, but we'll move the 9r over there so you get 17r, and then divide by 17, and you get negative 3 over 17. All right. Well, that's it. I hope that helped. Work hard. Be nice. See you soon.